Hello students, this is lab number 8. What we are going to do today is to develop a knowledge of how the magnetic field can bend the movement of a charged particle. And so in this case, the magnetic field is creating a circular movement of the electron. And you can see that there is a bluish circle inside the sphere. So from the radius of the circle, we can determine the ratio between the charge and the mass of an electron. What we are seeing here is the accelerating voltage, which is associated with the initial velocity of the electron, and the coil current here, which is the current that goes through the Helmholtz coils, and it will be associated with the magnetic field. So when we are varying the current here, which means that we are varying the magnitude of the magnetic field, you can see that the radius of the circular movement here changes too. So in order to investigate this, what we are going to do is to monitor the radius of the circular movement here versus the coil current. You can see that there is a ruler inside the sphere in this. And there are divisions and numbers on the ruler here. In this case, we can see that number 10 on the ruler is being lightened up, which means that we have the diameter of the circular movement equals to 10 centimeters. And then we record that with a coil current value here, that is 1.22. Then we will vary the coil current here to have another value of the diameter. It could be 9 centimeters here, and then you get the value of the coil current. Then you do that, repeat the procedure the same to have 9 values of the diameters along with 9 values of the coil current, then put into the first table. For the second table, you're going to change the accelerating voltage into another value, which is 300. And then repeat the same procedure, varying the coil current with different values of the diameters. And then the third table is going to be another table of the voltage, which usually be 400 volts. Yes. So after you finish all 3 tables, you are going to turn off this device. Turn it off and then remove the box. You can see that we have a pair of Helmholtz coils here. We can use the ruler here to measure the radius of the Helmholtz coils. So the proper way to measure this is to measure the inner and outer radius of that, and measure the vertical along the vertical direction, and then the horizontal direction, and then finally get the average of those values. And then you have let's say the best value for the estimate of the radius of the Helmholtz coils. So after you have the radius of the Helmholtz coils, you can use that value of the radius to put into the first equation in the post lab to get an equation for converting from the diameter of the circular movement here and the coil current here into the value of R times B, in which R is the radius of the circle, and B is the magnetic field created by the Helmholtz coils. You can have a number of values for RB for each table, and then you can use those numbers to analyze that. You are all encouraged to use Excel or whatever computer software to analyze this data, because it's a lot of data points, and it will be much easier if we use the software. One more notice that you have to pay attention in how you present the final result. There will be 2 notices. The first one is that there are 3 significant figures for the value, and when you are quoting the error, you have to remember that if we only have 2 decimal places for the value, then you only have 2 decimal places for the error.